Hey guys, my name is IBM and I'm recording the October-November 2024 papers. These are multiple choice questions and this is component 1 2. Do not forget to visit our website to download the past papers for free, www.caieresourcemaster.com. Um, Without wasting time, having seen paper 1 1, I want to go to paper 1 2 and direct to the questions. I normally don't want to go through the data because it's the usual data you are aware of. Question number 1. A physical quantity consists of a magnitude and a unit, which is true. Which row does not show a correct combination of a quantity and its unit? A quantity and its unit. Mass. Mass can be measured in grams. It's not SI units, but it's a unit for mass. Length can be measured in meters. Meters is the SI unit for length. Then charge. Charge can be measured in coulombs, so it can't be measured in amperes, so therefore this is not true. Temperature is a physical quantity which can be measured in Kelvin, so the answer is C. A small car travels in a town. What is a reasonable estimate of the kinetic energy of the car? So the easiest way to look at this is to try and see which masses do these energies give. Small cars, if we can assume that a small car is moving on a highway in a town, its speed could be approximately, okay, in a town, travels in a town, let's say the speed is approximately 60 kilometers per hour. Of course, in a town, the speed is supposed to be relatively low, but I'll take let me take 50 for simplicity. We just want to see which of these kinetic energies gives a reasonable mass. So I will select the speed, let the speed be, let's say 50 kilometers per hour. 50 kilometers per hour is the same as 50 times 1000 divided by 3600. Now I'll use 60 because I want something which is easier to manipulate. So I'll say 60,000, 60 times 1000 divided by 3600. So this is approximately 16.7 meters per second. Okay. So that is the estimated speed of a car moving in a town, about 16.7 meters per second. I can even round off this to approximately 20 meters per second, assuming it is moving at approximately 20 meters per second in a town. Then we know that kinetic energy is a half mv squared. So the mass is going to be twice the kinetic energy divided by v squared. So I'm going to check each of these with this formula here. For the first one, the kinetic energy is 5 times 10 to the power of 4. I want to see which mass is given by that estimated kinetic energy. So 2 times 5 exponent 4 divided by v squared, which is approximately 20 squared. So this is giving us a mass of 250 kilograms. 250 kilograms. The question was a small car. Okay. And I think the answer is most likely going to be A. Let's check the second one and see which mass it gives. Will it still be the same mass? Will it still be a mass of a small car? The second one is 2 times the kinetic energy, which is 5 exponent 7 divided by v squared, which is 20 squared. So this is 250,000 kilograms. 250,000 kilograms. This cannot be a small car, because even the normal relatively smaller cars could be as big as, could be up to about 1000 kilograms. But 250,000 kilograms, this can no longer be a small car. So it means this is wrong. It means this is going to give a bigger mass. This is also going to give a very big mass. So the answer is going to be A. A solid bar has a square cross section. which means the area is going to be side times side, which is side squared. Its length is measured as 50 plus or minus 0.2, and its width is measured as 2 plus or minus 0.01. So the width W is squared is going to inform the cross-sectional area. These values are used to calculate the volume of the bar. What is the percentage uncertainty in the calculated volume? So the area is the width squared, then the volume is going to be the area times another length, which is going to be the width squared times L. So because of a square, because of a multiplication, we are going to take the fractional uncertainty. So fractional uncertainty in the volume is given by that will be equal to twice fractional uncertainty in the width plus fractional uncertainty in L. The 2 is because W is width is squared. Then we take the percentage, multiply both sides by 100. So this percentage in V is going to be 2. Absolute in W is 0.01 divided by 2.0 plus absolute in L, which is 0.2 divided by 50.0, and this will be multiplied by 100. So from my calculator, I have from the calculator I have 2 times 0.01 divided by 2 plus 0.2 divided by 50. Then I'll multiply this by 100. So the answer is 1.4%. So this is plus or minus 1.4% exactly. So the answer is D. The graph shows how the acceleration of an object moving in a straight line varies with time. Acceleration with the time. So here, according to the graph, this is an increasing acceleration. This is approximately constant acceleration, decreasing acceleration. The object starts from rest, which means initial velocity is equal to 0. Which graph shows the variation with time of the velocity of the object over the same time interval? So all graphs are starting from 0, so we can't rely on this statement here to come to a conclusion. But we can look at a graph because we know if we have a velocity time graph, we know that the gradient equals to the acceleration. For a velocity time graph, the gradient is the acceleration. So let's look at let's investigate the gradient. From here, you notice that the gradient is increasing. Gradient increasing, which means the acceleration is increasing. So the acceleration increases for that part. Then around here, you notice that the gradient is decreasing. So here, acceleration is decreasing. Then around here, it is almost horizontal. The gradient is 0. So here, the acceleration equals to 0. So initially, acceleration should be increasing. So it becomes maximum somewhere around here. Then it starts decreasing, then it goes to 0. So the first graph is showing increasing acceleration. It becomes maximum somewhere, and in the middle, then it goes to 0. Therefore, the answer is going to be A. Gradient increases, acceleration increases. Somewhere here, around in the middle here, it becomes maximum. Acceleration is maximum. It increases to maximum because the gradient is maximum here. Then somewhere here, the acceleration starts decreasing, and at the last point, the acceleration is 0. So the answer is A. A stone falls vertically from rest. That means initial velocity equals to 0. Air resistance is negligible, so the equations of motion can apply because the acceleration is going to be constant. What is the speed of the stone when it has fallen through a distance of 0.4 meters? So I'll just use v squared equals to u squared plus 2as. So it means v is going to be the square root of, it started from 0, so initial velocity was 0 plus 2 times, the acceleration is going to be 9.81, then times s, which is going to be 0.4. So 2 times 9.81 times 0.4 square root. So this is giving us 2.8. So V equals to 2.8 meters per second. So the answer is going to be B. A ball is thrown horizontally off a tall building. Horizontally. I'll even sketch the motion. Let's say this is the building. So it is given a horizontal velocity, so it moves in that path, of course. So a ball is thrown horizontally off a tall building. The ground is horizontal. Air resistance is negligible, so the acceleration is uniform. Which statement about the motion of the ball is correct? So because air resistance is negligible, the acceleration is going to be uniform. Of course, in the horizontal, there is no acceleration. So let's see which statement about the motion of the ball is correct. The acceleration of the ball is always at right angles to the path of the ball. Always at right angles to the path of the ball. If it was always at right angles, it would cause centripetal force. The acceleration is always acting vertically downwards, and it is the acceleration due to gravity. So this statement is not correct. The ball follows a circular path until it hits the ground. It doesn't follow a circular path, it actually follows a parabolic path. So this statement is not correct. The path is actually parabolic. This path is not circular. The ball has a constant acceleration. Because air resistance is negligible, the ball will have a constant acceleration. Of course, zero acceleration in the horizontal and 9.81 in the vertical continuously. Since air resistance is negligible, so the answer must be C. A moving object strikes a stationary object. The collision is inelastic. The objects move off together. Assume that the two objects form an isolated system. So for an isolated system, total momentum is conserved. So total momentum remains constant, but because it is inelastic, kinetic energy is not conserved. Which row shows the possible values of the total momentum and total kinetic energy for the system before and after the collision? So momentum must remain the same, which means we eliminate A. A is showing total momentum before is different from total momentum after. For an isolated system of interacting bodies, total momentum is always constant. Then we have now to go to kinetic energy. The kinetic energy must be conserved. So let's check. Kinetic energy is not conserved, so it means we eliminate D. D is showing that kinetic energy is conserved, which is not possible for inelastic collision. But then if kinetic energy is not conserved, then it must be lost. It can't be gained from nowhere. It is lost. Therefore, kinetic energy after should be less than initial kinetic energy. So this means our answer is going to be C. It can't be B because B shows that kinetic energy before is less than kinetic energy after, which is that means the bodies gained more total kinetic energy after the collision, which is practically not going to be possible. So the answer is C. The graph shows how a quantity y varies with a quantity x for an object falling vertically at its terminal velocity. Terminal velocity means constant velocity towards the surface of the earth. Which quantity could x and y represent? Because this terminal velocity, v should be equal to constant. And if v is constant, it means the acceleration should be equal to 0. The acceleration is equal to 0. So let's see. It means none of these x and y cannot be velocity because none of them, they are not showing a constant velocity in any way. Therefore, where we have velocity, we ignore this because it can't be velocity. And if velocity is not constant, then kinetic energy is not constant. So kinetic energy, if velocity is constant, kinetic energy should also be constant. So because None of these is showing constant velocity, therefore none of these can represent kinetic energy. Therefore, this one is also not going to be correct. The acceleration is supposed to be 0 because that is at terminal velocity, the acceleration is supposed to be 0. That means to represent zero acceleration, one of these should be along the axis. And since none of them is along the axis, then it can't represent acceleration against time. So it means our answer is going to be B. So x can be time and y can be the height. The height decreases with the time. That makes sense. A ball of mass is 2 kilograms travels horizontally with speed 4 meters per second. The ball collides with a wall and rebounds in the opposite direction with a speed of 2.8 meters per second. The most important term is here, rebounds. What is the average force? So we know that average force is going to be the rate of change of momentum. This is going to be equal to the mass times the change in velocity over t. The mass is 2. The velocity changes from 4 to 2.8, but it rebounds. So if we say 4 is positive in one direction, the other one should be negative in the opposite direction. So it's minus negative 2.8 divided by the time, which is 150 times 10 to the power of minus 3. So we have 2 times, that is 6.8, divided by 150 exponent minus 3. So that is 90.6 recurring, which is approximately 91 newtons. So the answer is D. 2 train carriages, each of mass 5,000 kilograms, roll toward one another on a horizontal frictionless track. One is traveling at a speed of 2 meters per second and the other at 1 meter per second as shown. They collide and join together. So that means they move with a common velocity v, which we can find first. So momentum is mass times velocity. Total momentum before collision equals total momentum after collision. Total momentum before collision, because they are moving in opposite directions, I'll say this velocity is positive, this is negative. So we are going to have 5,000 times 2 plus negative 5,000 times 1. This should be equal to, when they combine, they form a total mass of 10,000 and move with a common velocity v. So this means v is going to be equal to 10,000 minus, so that is 5,000 divided by 10,000. So v is going to be 0.5 meters per second. That is the common velocity. They move with a common velocity of 0.5 meters per second. Okay? So what is the kinetic energy lost during the collision? So remember, kinetic energy is a half m v squared. So total kinetic energy is going to be the sum of the kinetic energy of all these ones minus kinetic, then we subtract the kinetic energy after the collision. So the change in kinetic energy is going to be equal to a half times 5,000 times 2 squared plus a half times 5,000 times 1 squared, then minus a half. Because they join together, they form a total mass of 10,000 times the speed, which is 0.5 squared. So this is the change in kinetic energy. This is initial, or this is before, and this is after. So I'll just press my calculator. 0.5 times 5,000, then times, I'll just say 2 squared plus 1, which is 5. Then minus, open brackets, 0.5 times 5,000 times 0.5 squared. So that is 11875. Let me check this again. 0.5 times 5,000 times 2 squared, which is 4, plus 0.5 times 5,000 times 1 squared, which is the same thing. Then minus 0.5 times 10,000 times 0.5 squared. So it's 11250. So this is 11250 joules. So the answer is C. Which single condition must apply? A single condition that must apply for an object to be in equilibrium. So the object has a constant non-zero acceleration. A constant non-zero acceleration, this means acceleration is not equal to 0. Therefore, the resultant force is also not equal to 0. So this cannot be equilibrium. The object is stationary. They said which single condition must apply for an object to be in equilibrium. The object being stationary is not enough to show that it is in equilibrium. There are no forces acting on the object. There could be forces acting on the object, but there could be no forces. If there are no forces acting on the object, there are no forces acting on the object. Which single condition must apply for an object to be in equilibrium? There are no forces acting on the object. This is not enough for an object to be in equilibrium. The resultant force acting on the object is 0. So for equilibrium, the resultant force should be 0. So the best answer is D. Of course, this also looks as if it's correct, but it doesn't make any good scientific sense. So the answer is D. A kite is in equilibrium at the end of a string as shown. The kite has three forces acting on it: the weight W, the tension T, of course tension acts away from the object in the string, and the force F of the wind. The force F of the wind. Which vector diagram represents the forces? So this, because it is in equilibrium, the three forces should form a closed triangle. So all of them are showing the weight vertically downward, so I cannot use weight to eliminate. The tension should be towards the side of the left. So we ignore this one. Tension should be towards the side of the left, so I ignore this one. Okay. I also ignore D. The tension should be towards the side of the left, away from the object. So we have to choose between A and C. Remember, they should form a closed triangle. For equilibrium, the three forces should form a closed triangle. Let's first check if any of these forms a closed triangle. So let's say moving around T, weight, F, that is a closed triangle. Let's check this. Moving around T, F, then the other one is the other way around. So this is not a closed triangle. So the closed triangle is the first one in A. So this is the answer to that question. Because in moving around, you move around a closed triangle. So the answer is A. For three vectors, three forces acting on a body in equilibrium, when combined head to tail, they form a closed triangle. C is not forming a closed triangle. Four forces act about a point P as shown in the figure. The forces act in the same plane and produce no resultant moment. They produce no resultant moment about P. What is the length X, Y? Okay. So I'm going to try and resolve this. I'm going to draw a vertical line here because we shall need the perpendicular distance of these forces from point P. So if I use these angles, this is 60, this is, I think this is 30. This will also be 30. Let's say this is 5 newtons. The other one is also 5 newtons. So let's say this distance is A and this distance is B. So I'm going to try and find the perpendicular distances. So using this vertical height, this distance here, adjacent hypotenuse, I think that is adjacent hypotenuse, I think that is cos. Students often have coffee and have tea or apple juice. I think that is cos. So this vertical distance is going to be A cos of 30, and this vertical distance is going to be B, this one here is going to be B cos of 30. So I'm going to take moments because there is no resultant moment. I'm going to take moments about P. So the 6 newtons form clockwise moments. The 5 newtons form the anti-clockwise moments. So the sum of clockwise moments is equal to the sum of anti-clockwise moments. So I'll have 6 times 7 plus 6 times 3. Those are clockwise moments. Should be equal to the anti-clockwise moments, which is 5 times A cos of 30, then plus 5 times B cos of 30. So this is 42 plus 18, that is 60. This is 5 cos 30 plus 5 cos 30. So that is going to be 5A plus 5B cos of 30 equals to 60. Alternatively, I can say A plus B is equal to 60 divided by 5 cos of 30. Let me check the sum here. 60 divided by 5 cos of 30. So this is 13.86 meters. So the sum of A plus B is approximately equal to 14 meters. So the answer is going to be C, because xy equals A plus B. A rectangular block of lead of density 1.13 times 10 to the power of 4 kilograms per meters cubed has sides of length 12 centimeters, 15 centimeters, and 10 centimeters. What is the maximum pressure the block can exert when resting on a table? So pressure is maximum when the force is divided by the smallest area. Smallest area. The force is divided by the smallest area. And the smallest area, so the smallest area is going to be equal to, we look for the smallest pair of dimensions, that is 12 and 10. So that is going to be 12 centimeters by 10 centimeters. Okay. So that is going to be the smallest area. And the force is going to be equal to the mass mg, which is going to be the density times volume, then times g. Therefore, the pressure is going to be density times volume times g divided by the area, which is going to be equal to density times the area times another length, which is going to be 15, then times g divided by the area. So the area cancels. So the pressure is going to be density times g times the 15 centimeters. Therefore, the pressure is going to be equal to density, which is 1.13 times 10 to the power of 4, then times g, which is 9.81, times the length there, which is going to be 15, times 10 to the power of minus 2. So 1.13 exponent 4 times 9.81 times 15 exponent minus 2. So that is 16628 pascals, which is about 16.6 kilopascals. So the answer is going to be D. What is the definition of power? We know that power is the rate of doing work. That's work done over time taken or energy transferred per unit time. So let's see the options which are there. Work done in 1 second, work done per second, that's not really power. Work done in a unit time, that's not really power. Work done per second, that is almost the same as that. Work done per unit time, so the answer is D. Now all these look as if they are correct, but power is the work done per unit time. So the answer is D. A model car travels at a constant velocity of 12 meters per second in a straight horizontal line. The input power to the engine is 800 watts. The efficiency of the engine is 60%. What is the total horizontal resistive force on the car? So we know that efficiency is going to be the power output divided by the power input times 100. Now the power input is 800. We can only find the power output. The power output is going to be the force times the velocity. So the efficiency is 60%, which is 0.6. So I'll say 0.6 is equal to the power times velocity. Because I changed it to 0.6, I may not need 100. So it will be force times velocity divided by the power input, which is 800. Therefore, the resistive force F is going to be 0.6 times 800 divided by the speed, which is 12. 0.6 times 800 divided by 12. So this gives us 40. So the force is going to be 40 newtons. Which statement represents the principle of conservation of energy? Of course, we know that energy can neither be created nor destroyed. This results into the total energy of a closed system remaining constant. So energy can be used faster than it is created. That's not true. The supply of energy is limited, so energy must be conserved. That's not true. Total energy in a closed system remains constant, so the answer is C. Energy can neither be created nor destroyed, which means the total energy in a closed system remains constant. A barrel of mass 50 kilograms is loaded onto the back of a lorry 1.6 meters high by pushing it up a frictionless plank 3.4 meters long. So because it is frictionless, there is no work done against friction. No work done against friction. No work done against friction. Which means the work done is just going to be equal to the gain in gravitational potential energy. So work done is just going to be equal to the gain in gravitational potential energy. And the work done, gain gravitational potential energy is given as mg times h. So mg is going to be the weight, and then height is 1.6. So the mass is given as 50 times 9.81 times h, which is 1.6. So what is the minimum work done? So 50 times 9.81 times 1.6, that is 784.8, which is approximately 780 joules. So the answer is going to be C. What is a unit for stress? So we know that stress is equal to force over area. The units for force are kilogram, meters per second squared, and area, meters squared. So the units for stress are going to be kilogram, meters per second squared divided by meters squared, which becomes kilogram per meter per second squared, which makes the answer to be A. The graph shows the relationship between stress, strain for three wires of the same linear dimensions, but made from different materials. Same linear dimensions, they have the same length, they have the same cross-sectional area, same length, same cross-sectional area. Okay, but from different materials, and Young modulus is equal to force over area times original length over extension. They have the same length, same area. Which statements are correct? The extension of P is approximated twice that of Q for the same stress. Let's draw a line, a horizontal line, and we see for the same stress, let's say this is the stress. And we see the strain for P and the strain for Q. They are saying the extension of P is approximated twice. We notice that strain is equal to extension of original length. And we notice that the strain of P is less than the strain of Q. So the extension of P cannot be twice, because strain is directly proportional to extension. So this is not true. The ratio of the Young modulus for P to that of Q is approximately 2. The ratio of Young modulus for P to that of Q is approximately 2. And we know that Young modulus is approximately equal to the gradient. Young modulus is the gradient. And when you check, the gradient of P is approximately twice the gradient of Q. So gradient of P is approximately the same as is approximately equal to twice, because P is steeper than Q. So the gradient of P is approximately twice the gradient of Q. So this one is correct. For strain less than 0.1 NC here, R obeys Hooke's law. For less than 1, we say straight line. This is a straight line. So R obeys Hooke's law. So this is also correct. So the answer is going to be 2 and 3 only. 4 solid steel rods equally support an object weighing 10 kilonewtons. Each rod is of length 2 meters and cross-sectional area 250 millimeters squared. The weight of the object causes the rods to contract by 0.1 millimeters. The rods obey Hooke's law. So let's say these are the rods. I'll just sketch the diagram here. So we have 1, 2, 3, 4. And they are supporting the same load. And they are saying the loads compress by 0.1. So that is going to be the extension. The area is 250. The extension is going to be 0.1 times 10 to the power of minus 3. So I'm going to first find, of course, total extension is the same. So total extension is 0.10 millimeters, which is 0.1 times 10 to the power of minus 3 meters. Now I'm going to find total constant. So the load F, which is the total effective load, is equal to total constant times total extension. So the total constant for the whole system is going to be the total for load, which is 10 newtons, that is 10,000, 10 kilonewtons, 10,000 divided by the extension, which is 0.1 times 10 to the power of minus 3. And I think this is going to be 1.0 times 10 to the power of, I think this is 8 newtons per meter. That is total constant for all the three, but there are three and they are like in series, I mean in parallel. Because they support the same weight, they're in parallel. So the constant K for 1 is just going to be this divided by 4. 1 times 10 to the power of 8, divide this by 4. And 1 over 4, that is 2.5 times, I think that is 10 to the power of 7 newtons per meter. That is K for one wire. Now I'm just considering one wire to find its Young modulus. So Young modulus is equal to stress divided by strain. That is force over area times original length divided by extension. But they said the rods obey Hooke's law. That means F over E is a constant. So I'll just say this one, F over E, is the constant K. So this is going to be the K times original length over the area. So K is 2.5 times 10 to the power of 7. And the original length, each had a length of 2 meters, divided by the area. I have to change 250 millimeters squared to meters squared is 250 times 10 to the power of minus 6 meters squared. So this is divided by 250 times 10 to the power of minus 6. Okay, so 2.5 exponent 7 times 2 divided by 250 exponent minus 6. So 2 times 10 to the power of 11 pascals. So the answer is going to be B. The graph shows how the length of a spring varies with the force applied to it. Two areas P and Q are labeled. Which area represents the work done in stretching the spring? Now this is length against force. Therefore the extension is going to be this one here. This is the extension. And we know that work done is equal to a half times F times X, where X is only the extension. So it is going to be this area here. If it was a graph of extension against force, then it would be the total area including Q. But since it is length, the extension is going to be just this part here, L minus L naught, that is the extension. So it's only going to be P, not P plus Q. So the answer is going to be automatically A. Area P shows the work done in stretching the spring because work done is a half times F times X, where X is the extension. A horizontal beam of vertically polarized light of amplitude A is incident normal on a polarizing filter. The transmission axis of the filter is at an angle of 50 degrees to the vertical. What is the amplitude of light in the beam after it has passed through the filter? So we know that by Malsey's law, I is equal to I naught cos squared theta or cos squared phi. So for the first one, I will say I1 equals to the incident, let it be I naught cos squared phi. That is for the first one. And when we make a substitution, or when we just simplify this, I1 over I naught is going to be equal to cos squared of 50. Okay. So a horizontal beam of vertically polarized light of amplitude A is incident normally on a polarizing filter. So before passing through the filter, I is going to be equal to K times the amplitude A, I will call it A squared. before passing through the filter. After going through the filter, the intensity transmitted is going to be I naught cos squared. So let this be I naught anyway. It's going to be I naught cos squared phi. So I1 is going to be I naught cos squared phi. I1 is going to be I1 over I naught is going to be cos squared that. And the question is, what is the amplitude of the light? So let's say the amplitude of I1 is A1. So I would say I1 is also equal to a constant times A1 squared, because amplitude is directly proportional to the intensity is directly proportional to the amplitude squared. So we have this one for the incident intensity, and we have this one for the transmitted intensity, and I'm going to substitute in this equation here. So I'll say K A1 squared over K A squared is going to be equal to cos squared of 50. So the square goes off, and we remain with A1 over A equals to cos of 50. So A1 is going to be cos 50 times A. What is cos 50? So cos 50 is 0.64. So A1 is going to be 0.64 times A. So the answer is going to be C. A progressive longitudinal sound wave moves through air. The diagram shows the positions of the air particles along part of the wave at one instant. Point Q is a distance x from point P. We notice that from P to Q there is a change in pressure. That means from lower pressure to high pressure to low pressure again. It means this has moved through from one low pressure position to another low pressure position. So x is most likely going to be wavelength. X is most likely going to be one complete cycle. So this is half a cycle. This is another half a cycle. So this cannot represent displacement against distance. Which graph shows the variation of the displacement of the air particles with the distance from P along the wave? So A and B are eliminated because they are showing half cycles. Then at X, we notice that the particles are getting closer, so they are under high pressure, which corresponds to zero displacement. So at half X, by all means, the displacement is going to be zero. So here we have zero displacement. At the center or half of the distance X, the displacement should be zero. And when I look at the two graphs, I think the answer is going to be C, because halfway of X, the displacement goes to zero. Yet here, half of X, the displacement is maximum. So this will be out of the equation. An electromagnetic wave in free space has a frequency of 3 times 10 to the power of 16 Hz. Which rho gives the principal region of this wave, and an example of an electromagnetic wave with a lower frequency? Okay, so do not forget, Reed's mother is visiting Uncle Xavier's garden. And they said it is an electromagnetic wave in free space with a frequency of 3 times 10 to the power of 16 Hz. What is this wavelength here? So the wavelength in that case is going to be the speed, which is 3 times 10 to the power of 8, divided by frequency, which is 3 times 10 to the power of 16. And this is going to be 3 exponent 8 divided by 3 exponent 16. So the wavelength is 1 times 10 to the power minus 8 meters. And of course, visible light is 10 to the power of minus 7. So minus 8 meters, because here wavelength decreases in this direction. This is decreasing wavelength. So 10 to the power of minus 9, minus 18 must be ultraviolet. So principal region is most likely ultraviolet. So it's not A, it's not B. Then which law gives the principal region of this wave, and an example of an electromagnetic wave with a lower frequency. Lower frequency must have a higher wavelength, so it should be, we need to look for a region on the left of ultraviolet. Visible light is on the left, X-rays is on the right. So visible light must be having a lower frequency than ultraviolet because visible light has a higher wavelength, and wavelength is inversely proportional to frequency, so the answer is going to be C. X-rays have a higher frequency than ultraviolet. A source of sound emits waves of a constant frequency. The source moves at a constant speed in a straight line relative to a stationary observer. Which velocity of the source gives the smallest observed frequency? So for the frequency to be smallest, it must be moving away in the first place. It must be moving away. Direction must be away, not towards. So we ignore C and D because these ones are showing towards. Then let's check. We know that the observed frequency is going to be equal to V over V. Because it's moving away, the denominator should be plus the speed of the source, then times Fs. Because this is the same, this is the same, this is the same. Now the smallest is going to depend on the speed. The smaller us is, the higher f naught is. The bigger us is, the lower f naught is. So the answer is going to be B because the speed of 10 is bigger than 5. So if us is big, then f naught is smaller. So the answer is going to be B. What could describe the time base of a cathode ray oscilloscope? Of course, the time base is like the number of divisions per second. Number of divisions per second or centimeter. Number of divisions, time per second, or time per centimeter, or divisions, time per division or time per centimeter. Let's see what is here. So the time base, of course, it gives us time, something related to time. We have the frequency per division. Of course, the time base is not the frequency per division, because when you look at the cathode ray oscilloscope, on the vertical you get a V, on the horizontal you get time. So the time base cannot give us frequency directly, frequency per division. However, it can give us time per division or time per centimeter. The frequency per division is out. The number of divisions on the screen per unit frequency, that is out. The number of divisions on the screen per unit time. Number of divisions per unit time, that's also out. The time per division on the screen, so the answer is going to be D. It's a representation of time, is a representation of time by the divisions which are displayed on the screen. That is the time base of the cathode ray oscilloscope. Of course, the Y setting is a representation of the voltage per division on the Y-axis. What happens when two waves superpose at a point? That is when they overlap. Of course, when two waves superpose at a point, the resultant displacement is the algebraic sum of their displacements. So the displacements add up. This one is showing their amplitudes are added together. Amplitude refers to only maximum displacements. Yet when two waves interfere at a point, all the displacements, even when they are not the maximum displacements, they add up. So the answer is going to be B. It can't be amplitudes. It is their displacements are added together. An electromagnetic wave is diffracted as it passes through a single slit. The width of the slit is larger than the wavelength. So width is larger than the wavelength. Which change will decrease the amount of diffraction of the decrease? The width is larger than the wavelength. Already we have smaller diffraction. Now, the change should also make either the width even bigger or the wavelength even smaller to decrease the diffraction further. Decrease the frequency. When the frequency decreases, the wavelength increases. That means it is tending towards the same size as the width. It is tending towards the same size as the width. So this would increase diffraction instead of decreasing it. So this is out. Then number 2, decrease the time period. Period equals to 1 over frequency. When we decrease the time period, we increase the frequency. And if the frequency is increased, the wavelength is decreased, which means the wavelength is going to be much, much smaller. Again, more smaller than the width. Hence, less diffraction. So the answer is most likely going to be B. When you decrease the time period, you increase the frequency. Increasing the frequency means we decrease the wavelength. That means again the wavelength will be much, much smaller than the width, hence less diffraction. The diagram shows visible light incident normal on a diffraction grating. The pattern, so this is a diffraction grating, and of course we know the expression for diffraction grating. We know that n lambda is equal to d sine of theta. A pattern of intensity maxima forms on the screen, a line connecting the center of the fourth order. Center of the fourth order, so n equals to 4. N equals to 4. Intensity maximum width with the center of the diffraction grating forms an angle of 53 degrees with the center, so theta is 53 degrees. The grating has a line spacing of 2.7 times 10 to the power of minus 6, so d is 2.7 times 10 to the power of minus 6. What is the wavelength of the incident light? So wavelength is going to be d, which is 2.7 times 10 to the power of minus 6 sine of 53 divided by n, which is 4. So 2.7 exponent minus 6 times sine of 53 divided by 4. So that is 5.39 times 10 to the power of minus 7 meters. So the answer is going to be 5.4 times 10 to the power of minus 7 meters. A horizontal glass tube closed at one end has a layer of dust laid inside it on its lower side. Sound is emitted from a loudspeaker that is placed near the open end of the tube. The frequency of the sound is varied. At one frequency, a stationary wave is formed inside the tube so that the dust forms small heaps. The distance between 4 heaps of dust is 30 centimeters. So of course, wherever we see the heaps, it's because particles there are permanently at rest. So these should be positions of the nodes. So there is a node here, a node here, a node here, a node here. So 30 centimeters is the distance between 1 to 3 loops, because these are going to be four nodes. Those are 3 loops. So the speed of sound in the air is 330 meters per second. What is the frequency? What is the frequency of the sound emitted by the loudspeaker? So we can find the distance between the node and a node and a node. So the distance between one node and the next node is going to be equal to 30 centimeters divided by 3, because these are 3 spaces, 1, 2, 3. So 30 centimeters is divided by 3 is the distance between only 2 nodes, which is going to be 10 centimeters. And we know that the distance between a node and another node, the next node is always half wavelength, which means that the wavelength is going to be 2 times 10. times 10 to the power of minus 2 to change it to meters. So the frequency is going to be speed divided by wavelength, which is going to be 330 divided by 2 times 10 to the power of minus 2. From the calculator, we have 330 divided by 2 times 10 exponent minus 2. So that is 1650. So this is 1650 hertz. So the answer is going to be A. There is a current in a resistor for a short time. Which statement about the total charge that passes through the resistor is correct? Remember, charge equals to current times time. And of course, we know that total charge is the number of charge carriers times the charge of each charged particle. So Q is the number of charge carriers times the charge of each charged particle. So charge takes on any value. That's not true. Charge is quantized, takes on values which are a whole number times the elementary charge. Charge is an integral multiple of the elementary charge, so the answer is B. Charge is a number times E, an integral multiple of the elementary charge, so the answer is B. The potential difference V across a filament lamp is slowly raised from 0 to its normal operating value. So as we move to the operating value, of course, the temperature increases. The temperature increases, and as temperature increases, then the resistance also increases. Resistance increases. Which graph represents the variation of V of the current in the lamp? Of course, for the IV characteristic graph is A, because we know that the gradient is going to be equal to 1 over R, or R is going to be 1 over the gradient. And how do we, because we know that the resistance increases, if the resistance increases, then the gradient should be decreasing. And this one is showing that the gradient decreases. The gradient decreases. The gradient is decreasing in this case. That means the resistance is increasing. So the answer is A. For filament lamp, the IV characteristic graph is that this will be an ohmic conductor. That will be an ohm conductor, I think. So the answer is A. An electric current of 12 amperes is in a wire of length 0.35 meters. The average drift speed of the free electrons in the wire is 5 times 10 to the power of minus 4 meters per second. How many free electrons are in the wire? So of course we know that current equals to charge over time, which is the number of free electrons times the charge of each electron, then divided by T. And of course, because we have the speed and the length of the wire, then the time, T, is going to be the distance times the speed. Therefore, the current is going to be the number of charge carriers times E divided by the distance times the speed. So I'm going to make N the subject. So N is going to be equal to the current. No, time is equal to distance over speed. So this is distance over speed, not distance times speed. Distance over speed. So this is going to be I times distance divided by V times E. So this is I is 12. The distance is the length of the wire, which is going to be 0.35, divided by the speed, which is 5.0 times 10 to the power of minus 4, times the charge of each charge carrier, which is 1.6, times 10 to the power of minus 19. So I'll just press my calculator. 12 times 0.35 divided by 5 exponent minus 4 divide by 1.6 exponent minus 19. So that is 5.25 times 10 to the power of 22, which is approximately 5.3 times 10 to the power of 22. So the answer is B. 3 resistors are connected to a cell of negligible internal resistance. Which resistor has a combined resistance of 100 ohms? Let's check. So here total resistance is going to be equal to 100 plus, because these are in parallel, their total will be product, that is 100 times 50 over the sum, which is 100 plus 50. What is the total here? 100 times 50 divided by 150 plus 100. So that is 133.3. So this is out. Then B, the total resistance here is going to be 50 plus product over the sum, that is 100 times 100 over 100 plus 100. So this is 50 plus 50, which is 100 ohms. So the answer is B. Each of Kirchhoff's laws is a statement based on the conservation of a physical quantity. Of course, we know the first law is conservation of charge. The sum of currents into a junction, that is sum of currents into junction, equals the sum of currents out of a junction. That is conservation of charge. That is the first law. The second law is conservation of energy. That is the sum of EMFs is equal to the sum of PDs. This is conservation because EMF and PDs, those are energy per unit charge. So this is conservation of energy. So first law, charge, second law, energy, which makes the answer to be A. A cell with EMF 1.5 volts delivers a current of 0.26 amperes to a resistor of 5 ohms connected between its terminals. What is the internal resistance of the cell? So we know that the EMF equals the terminal PD plus the lost volts. So this means 1.5 is going to be equal to the terminal PD, which is going to be the current times the external resistance. The lost volts is going to be the current times the internal resistance. So we say 1.5 equals to, the current is 0.26, the external resistance is 5, plus the current is 0.26 times the internal resistance. So the internal resistance is going to be 1.5 minus 0.26 times 5. Then divide this by 0.26. So 0.26 times 5, 1.5 minus the answer, divide by 0.26. So that is 0.769, which is approximately 0.77 ohms. So the answer is D. What is not a quark flavor? We know that there are 6 quark flavors. We have up, down, top, bottom, charm, and strange. So we have charm, we have strange, we have up. So this is not a quark flavor. How many down quarks are in a nucleus of hydrogen 3? So hydrogen 3, we see it has 1 proton and 2 neutrons. So 1 proton, that is up, up, down. Then 2 neutrons, that is 2 into up, down, down. So we want how many down quarks? So here we have 1 down quark, and here we have 2 up and 4 down. So total is going to be 1 down quark here plus 4 down quarks here, giving us a total of 5. So total is 5 down. And lastly, an isotope of boron decays to beryllium by beta plus emission. So boron, you don't even need to know the symbol. Boron is decaying to beryllium plus beta plus emission. Which particle is emitted in addition of a beta plus? A beta plus is always accompanied by a neutrino. Because beta plus is an antiparticle, it's always accompanied by a neutrino. So the answer is going to be automatically C. I think that should be the end of this paper. And see you in the last paper, multiple choice paper. Until next time, in case I've made a mistake, you can always write a comment. For the teachers who don't really, who just want to criticize this, I feel sorry for you. Until next time, bye bye.